Hello once again. So welcome to Maths with Ish. Now we have a question on inequality today, and it's saying we should to present this, we should show this on a graph. Okay, we should leave the solution, the region that contains the solution to these inequalities. We should leave that region unshaded. Now this is how to go about it. Now the first thing you will do, or the first approach I normally use, is I will first of all test the validity of each of these inequalities. Now, how do we test the validity of each of these inequalities? Just use when x is 0 and y is 0, okay? So when x is 0 here and y is 0 here, what will happen to this inequality? We are going to have 0 is less than or equal to 10. When y is 0 and x is 0, I'm going to have everything here as 0 is greater than or equal to 4. When y is 0 and x is 0, I'm going to have 0 is less than 5. Now let us see if these statements are valid. 0 is less than or equal to 10. This is actually a valid statement. So this inequality is valid. Let me tick it good. Please take note of that. I'm ticking this good because this statement is valid. Here, 0 is greater than or equal to 4. 0 cannot be greater than 4. So this statement is not valid. I'm ticking it bad. Here, 0 is less than 5. This statement is a valid statement. I tick it good. Now, take note that the ones I ticked good are the ones that are valid, okay? The ones I ticked bad are the ones that are not valid. Now, let's go now. The next thing I'm going to do is to get the intercept of each of these inequalities. The intercept simply means where the line of the inequality crosses either the x-axis or the y-axis. So how do we go about that? The first thing to do is to change each of these inequality sign to equal to sign so that we'll have an equation. So I'm changing each of these inequality sign to equal to so that I will have an equation that will now help me to get the boundary line. So now, how do I get the boundary line, which is how do I get the intercept rather for each of them? So we start when x is 0, when x is equal to 0, y will become 10. And when y is 0, this x becomes 5. So my intercept for this inequality now is y is 10, x is 5, which means my line will pass through where x is 5, which is here, and where y is 10, which is here. So I'm going to draw a thick line to join those 2 points, okay? So we do the same thing when x is 0. What will happen? When x is equal to 0, y becomes 2. When y is 0, x becomes 4. X becomes 4. So my inequality, the line will pass through 4, where x is 4, which is this point, and where y is 2. Let me assume my 2 is here, okay? So my inequality will pass through these 2 points. These 2 points. Okay. Don't mind my line. It's supposed to be a straight line, but my finger is just Okay, so let's label the line. Remember, this first one I drew is for this, which is y plus 2x equal to 10. And then this second line is for this, which is 2y plus x equal to 4. So let's get this third one here. When x is 0, our y becomes 5. And when y is 0, our x, when y becomes 0, our x becomes minus 2.5. So minus 2.5 will be somewhere here, here. Okay, so I'm having x minus 2.5 and y is 5. So the line will pass through these 2 points. And this is less than, so it's going to give, we are going to have a broken line passing to that point. So let me join it with a broken line. So this is my line, and this is sorry, these are supposed to be straight lines. Don't mind my hand, okay? It's supposed to be straight lines, okay? So this is for the boundary line y less than minus 2x equals to 5. So I've drawn all the boundary lines now. So all I have to do now is just to show the region that represents this. Now let's come back to all this validity and stuff I've marked here. Remember, now this is a valid statement. Anytime the statement is valid, remember the boundary line always divides the entire graph into two parts. So let's come to this one. This is the boundary line. So this boundary line has divided this entire graph into this region and this region. Now, anytime the statement is valid, the region that contains the origin will be left unshaded. That is the acceptable region. Okay? So, if I check, considering this boundary line, this region is where contains the origin. So, I will leave this side unshaded. I will shade this entire part. I'll shade this entire part. I'm done with that. Let's go to this next one, which is 2y. This boundary line divides this entire graph into this part and this part. This is not valid. This is marked bad, so this statement is not valid. Anytime it's not valid, the region that contains the origin should be shaded. So I'm going to shade this origin, this region that contains the origin. So do you get the idea now? Whenever the statement is not valid, shade the region that contains the origin. Anytime the statement is valid, leave the region that contains the origin unshaded. Let's go to the last one now, which is the line, the boundary line for y minus 2x. That's this one. This is the line, and this line divides the graph into this part, this region, and this region. This region contains the origin. This region does not contain the origin. This statement is a valid statement. So this region that contains the origin, I will leave it unshaded. Therefore, I'm going to shade this other part. Do you understand now? So you can now see the true solution to this problem. Can you see now? So the region that contains the solution to this problem is this unshaded region. And that is the solution to this problem. I hope you found this very useful. Thanks for watching. Don't forget to share.